Okay, so I have posted the videos on the videos page from last sessions or the prior session. So if you have my YouTube channel, you will be able to see all my classes lecture on there. I teach from beginning level for most part, not too beginning, but all the way to advanced level in security here. And also programming. You've probably seen my video for Java and Python and other Python classes on there as well. So I will be able to share with you the video once I have it downloaded and uploaded to YouTube. So that takes a little bit of time. So hopefully by tomorrow, it will be linked to your assignment page. And then I will have a lab video also, right? Okay, so let's talk a little bit about some of the terminology, and that way we can answer some questions. So as you go, right, look at the notes, but we ultimately want to answer all the questions on your assignment. So your note is like a reference document that you can find most of your answers on there. But I want to explain this so you can understand, okay? So what would be consist of a network? A network is when you have at least two or more systems connected together. So if you are using your phone, right, to be able to watch your TV series, you are connecting your TV to your phone, you have a small network. If you have a couple computers at home connecting to your wireless router and your printer is connecting to your wireless router, you have a small network, right? So it consists of two or more systems. Now, all the data is being passed in digital format, which is in 0 and 1s, right? So everything breaks it down. But wait, so when I make a phone call, let's say I'm connected to the wireless network, I'm calling my friend, right? Your voice is an analog format, and it gets converted into a digital format before it gets sent from your system to the rest of the network. Okay? So everything is going to be encapsulated and decapsulates from the beginning. So when I speak into my phone, your voice is an analog. Your system has a converter. It converts your analog waves, your sound, into 0 and 1s. And it becomes data packets. Okay? Consists of binaries. And from there, it's going to be able to send, right, from your smartphone through the wireless router, right, into the larger network, into the wide area network, aka your service provider, right? Your T-Mobile or Verizon, etc. Now, when it gets to the destination, it's going to encapsulate. So when it encapsulates, it converts your sound into the digital, but when it gets to the recipient who's hearing the voice on the phone, that system has to convert it back into sound. So it has an analog, right, digital converter. So it takes the data packets and convert it back into sound. So that's what you hear people talking on the phone. People with FaceTime, right? It's transmitting video and sound at the same time. So your devices sometimes would have those type of converter. Now, you might hear the term host. So if you're familiar with Linux system, it treats everything as a host, right? Like your computer is a host, another computer is a host. So a host is just a system, right? A host can be a smartphone, a host can be a PC, a host can be a laptop, a host can also be a server, right? But a server is a server. It provides service to other systems. Now, a client is a system that's connected to a server, right? So a host can be a vast amount of things, but a client it needs to be connecting to a system that provides service, aka the server. Okay, so let's answer some questions. So for our assignment, for number 1, it asks you, what is a network? So we talked about how it consists of 2 or more connected systems. You can wirelessly connect it. You can connect it with cables. And ultimately, we build a network to share resources, right? A network exists so that way we can share data. So back in the day, you probably heard this from other professors and books and other sources. there's SneakerNet, right? When we transfer data, we put it on a floppy disk, and then we put on our sneaker, and we run it upstairs or downstairs. That's how we transfer data. But long gone the 70s and the 80s, some of you, your parents were born in that era, like myself, right? We now have a network that we can digitally share our data, our application, our resources, right? And even like print, right? We can share printers. So it is a way for us to maximize the resources in our work environment or in our business. Now, when we get into what consists of the local area network. So a local area network, when you hear the term LAN, L-A-N, it is really a network that belongs to that specific location. Okay, like at home, you have a wireless local area network if you're using the wireless router. You're sitting in front of the LAN right now, right? It belongs to Moreno Valley College. All the systems are connected together. So it's really tied to that geographic location. So if I go to Norco College or RCC, they have their own LAN, correct? And all the three colleges are tied back together in the district LAN, right? So if you go to the bank, like Bank of America in Moreno Valley, right? Using the ATM machine is connected to the network for Bank of America for that location. Moreno Valley, Bank of America link. And that LAN might be connecting to the Riverside branch, right? And then ultimately in the larger scale, their corporate is out of Texas, Dallas. So all the network system funnel back to the corporate office. That's where they manage security, applications, and a lot of things. So that has to be communicated via WAN, wide area network. So a LAN really consists of, right, that particular network location. So when I move beyond the LAN, right, it's kind of like you live in this town. If you want to go to the next town, you have to jump on the highway or the freeway to get to the next town, correct? Like if I go from here to Corona. So you need to have a router that takes you from one LAN to the next LAN. So the router is kind of like the highway that's going to take you from one town, one city to the next town. Okay? The switch, its job is to get all the systems connected. Your computer, this computer, their computer, everything connected with the switch. Internally, that's kind of like all the street connections inside the town. But when you get from one town to the next, you have to go into the wide area network. What takes you there? The router. Okay. Okay, so some examples. A network that consists of your computers, your servers, your printers, your mobile devices, right? And we do that to share resources. Some of this will come up on your quiz. Next is going to be a work group. So basically, it is a way that we can simply create a smaller network for a certain section, okay? But work group is traditionally, it is an old way to set up a small group of systems. And we can make it where it would be a department, right? Or a sub part of the department, like a division of the department. So for example, I might have like a finance department, but in that I might have account payable, so I can set up a work group for account payable, right? And then, and so on. So you might be able to think about how you want to really control, right, the physical communication of your system by subsection it into some areas, right? Like making it into a work group. So an example of this would be like department work groups or even home networks. You might have like systems connecting directly with another system, like a peer-to-peer. But for work group, usually you see this as like smaller groups. So that way we can control some resources with that. Now, earlier, I talked about wide area network, right? A wide area network really consists of, let me move it up so we can see, sorry. A wide area network usually consists of getting past the router, right? Remember when I said if I want to go from Moreno Valley to Corona, I have to hop on the freeway, right? I can't take side streets, but I'll do it for a long time. So think of the freeway or the highway as your router. The router is going to take you from your network to the next network. And that's how you're able to visit the web, the internet. It's going to go from your home network to your service provider network, right? To ultimately like google.com or youtube.com. So can I follow this traffic? Yes. Okay. I know some of you have learned commands before, right? So in your command prompt, you can do a trace route, trace RT, or in Linux, trace route, right? So we can put in the IP address for the target, and we'll be, or the website or the domain, we'll be able to follow it. It's kind of like putting a camera in your car and watching you going through all the highway to get from something to something. Okay. So a WAN would consist of a router, right? And the router, the way it communicates is a port. So what is really a port, right? It could pertain to a physical connection, right? Like a port number blank. It could also pertain to a logical connection, right? So think of ports as door or windows to your home. In order for you to have people visiting you, you have to open the door, right? So that door allows visitor to come in, data to come in from other locations, someone who sent you the data. Now, if you're using a specific service like web, it could be port 80 or HTTP, it's like a specific door or window, right? It cannot just go to any door or window, any port. It has to be that specific port. It's kind of like, you know, how when we go to the DMV or an office where they tell you, like, if you need your driver license, you're gonna be in this line and you're gonna get visited by that person in that window, right? So a port is like that. It's specific for a certain service. So think of that door is only used for that particular traffic. Now we can use it for private or public data. So basically we send data through cables or, you know, it could be fiber or coaxial, copper cable, wireless, right? And your data could be entering into the public network, or your data could be passed directly in a private. It's kind of like taking the toll road from here to San Diego. You never enter the public freeway, right? So private ways to send the data, we have to set up a dedicated path, right? From one door at one house to maybe a home in San Diego directly for that path. When you see this, when you have sensitive data like government research data, right? When you have public data that might not be too sensitive, that can be transmitted into the internet, but we always use encryption to protect data because a lot of the data that we use are confidential or highly secret, right? It's like your credentials is confidential and private. And there's privacy law that we have to follow. Any questions? So make sure we know LAN and WAN, right? So when you see a job, ability to administer LAN, basically be able to manage and administer your local network, right? Like at a school or a business. And you don't have to write verbatim, right? You can summarize it how you perceive the answer would be, and I'm okay with that. I want you to understand, and that's important. Okay, let me move 2 down because some of you are still recording that, I'm sure. Sorry, because it's gonna get cut off on the next page. And then let's move 3 up. Now, the questions doesn't always cover all the entire thing. So when you go through here, right? One of the things I didn't include was MAN, M-A-N, right? I'm sure that when you took A+, it talks about that. So it talks about the advantages of having a work group and the disadvantages of having a work group. Just like everything else in network design, you will not have a perfect network design. People design network usually for performance, right? And resources, meaning how much money do you want to put into that network? For example, right now, every network is a fiber network, right? Because that's cost. And also not all network would have all the servers. So what happens is we can rent a network using the cloud, like AWS or Azure with Microsoft, right? So look at the drawbacks, the disadvantages. Now you can have network designs, that's great, but there's always drawback in network design. Okay. Okay. And then peer-to-peer is when you are using a system that's equivalent in role, like your TV and your smartphone, right? You're able to watch your Apple shows, your app for our Apple TV or Android, you can do that and be able, or you can connect your laptop to your PC so you can share data or sync data. It is a way that we can connect two systems at equivalent in role. There's no client or server environment there. Okay. Peer-to-peer. Okay. So some of the things that wasn't on the questions were your workstations. So a lot of people get mixed up with the difference between workstations. I'm sure that you might have covered this in A+. So workstations usually have more hardware than what you have with your normal consumer PC. It's really designed for network environment, and they tend to be a client system that's connecting to a service system or a server, right, in a larger network. So what you see here is basically a workstation is just a computer, right, that might be more equipped with hardware, like processing power will be higher, more memory. So in the business environment, they often refer to your system as workstations instead of just a PC, right? And when you look up the price for that, they are higher because of the hardware that they're equipped with. And then the servers would have better hardware. It's able to provide service to many systems. So if you have a web server, you better have the processing power, because if your website is popular, right, you're going to have a lot of requests. So if you don't have processing power and bandwidth, network bandwidth, your website's going to be crawling slow. Who wants to visit a website? Let's say if I go to YouTube and it takes me 5 minutes to load a video, I'm not probably not going to come back. Right nowadays, everything needs to be instant. So you want to have high throughput, high performance, especially for the type of service that you're using, okay, or providing. Okay. Okay, so we touch a little bit on that, but let's talk a little bit more about intranet and extranet. So old technology, old term, but it's still being integrated today, right? Intranet, we can create this to be able to, again, share information and resources, could be collaboration tools. So when you see that with companies. So let's say that I have a company and I want to build an intranet to be able to share benefits like health benefits information to my employee, right? Resources to my employee. They're able to have access to the forms in the case if they want to file a claim for their health, etc. Right? So I can build a computer network that's part of, an extra part into my land to be able to only focus on that, right? Because I might have a very large corporation and I don't want to take up, my local area network bandwidth just, in addition to that. So we can also set up an intranet and we can also provide like a portal, like what you see with student portal, right? Or employee portal for them to access these resources. Okay, so you see that common, and then you have extranet. So for example, like AutoZone or Walmart or Target, all the retailers, they buy their supply from somewhere, or even Starbucks. I'm sure you all know the story, even if you don't visit them, right? So for example, Starbucks might need coffee cups and stirrers and sugar and, so that part of the supply chain. But it doesn't come from one supplier, right? You know that. They might buy their coffee cup maybe from Dixie, right? Or another company. They might buy their sugar from another brand, another company, right? So extranet is really designed for partners and suppliers to be able to connect with the company to be able to sell, right, or exchange information. So I have a friend that works for Universal Studio. And Universal, just like Disney, they sell a lot of products, right? You know, related to movies like T-shirts, pajamas, I don't know, bunch of things, school supplies. And what he does is he manages the national databases for all the retailers. So if Target or Walmart, right, if they order, let's say, 10,000 pajama sets for kids that's related to a movie, right? They use an extranet to update the databases and synchronize, right? Companies use invoice to pay. So upon shipment, when they receive it, right, they would get invoice, they bill the other company so that way that the money can be paid, right? It's all about credit and account. So they have to track that through the database, and extranet will be good for that. It's good for the supplier to track how many items you need. Okay. But then it's also good for the retailer to say, okay, this product is really hot this month because it's all over saturated. I'm gonna need more. So if they're able to do the data analytics and say, okay, I want maybe additional shipment in this area, so extranet is the gift for that. Okay, with database resources. And normally you see this in the demilitarized zone. So if you took security plus class, right, or you took classes that talk about D&D, so basically it is public spaces. These are the server systems that are connecting so that way people can come in and access it from the internet. However, when we do a D&D, we want to be able to protect it. Because I don't want people to find account information and modify my shipment data, right? That would be wrong. What if I receive like 1 million more products and now I'm owning that company, right? So I want to be able to have like firewall and things to protect it. We talked about workstation already. So these are the systems, right? That's in a business environment. Yes, question? Yeah, it can be. So it says extranet is similar. So what happens is you can have a database. So the downfall right now in security is that, right? Access to partners and suppliers that they're able, because you have external people that's accessing that part of your network and it's not well protected. So what happens is the attacker, they're coming in from that route to be able to take down supply chain, because now they're able to modify or access like database information that belongs to the supplier. So if you go to AutoZone or Auto Parts Store, maybe some of you are familiar with this, right? you have to look up part numbers and all of those things. They have to manage all of that, like an oil filter is not just an oil filter, there's like 100 different types of oil filters for many different types of vehicle, right? So, I mean, supplier has to be able to track like which oil filters they send to AutoZone, right? Or these stores. So that has a lot of the time they're coming in from the internet, which is what we call the public side of the network. They authenticate to the extranet and log in to the database, and then they're going to be able to see like, oh, there's, I need to send oil filter for a Ford Ranger, whatever, right, to this company. So, now we have to really take care of the security part in that. When you're looking at it from a security perspective, extranet, when we assess the risk in that, you gotta check and make sure that authentication and access and privilege permission management is there. Okay. Questions? Okay, let's talk about server role, which is part of, and you can copy and paste from the notes. You can summarize whatever you want, right? Let's talk about file server. File server can be also labeled as storage server. I think Microsoft, that's what they label the role now. File server is important. It is able to dispense files. So you might not think about that, but YouTube has file server, right? All these videos that are uploaded to go into some kind of container and manager. Because Casey might have 500 videos or 1,000 videos, and then there are content creators that have 20,000 videos, right? So file server is really a way for us to manage files, right? How those can be shared. Okay. Now, YouTube specify that once you upload the video to their service, it's 100% public. You can make it private, but nobody else can view it. The whole point is to the web application to do video, right? So you have to make it public so that way other people can see. Now, file server, we can use it to manage permissions for the file. So whenever we talked about objects like files and folder, we talked about permissions to control the file. Then we have mail server. So if you log into your student account, your student email account, that is handled by Microsoft Exchange, right? Now, if it's not Microsoft, it'll just be an Exchange server. So that role of the server is only able to circulate mail, right? Bring mail in from outside sources. Like, so if I'm an external siter, I can send an email to my professor or a potential professor to ask for an ad code that will go through a mail server. The majority of the companies use Microsoft Exchange. Okay. So think of it like a role. Okay. All these servers are a role, and within that role, it has a certain type of services that would provide resources for the rest of the network. Your print server. This allows you to manage print. Some companies, they don't want you to print a lot. So I know here, right, if you go to the library or something, if you want to print, they charge you, right? But other companies, you have to print, right? So print server can be a system like your PC. But a lot of times it is an actual server system because you might have a lot of print. So imagine working for a copier, a photocopier company, or they used to be Pinko, but now you go to Staples, right? You can get some kind of service where you can print a document with a copy or paste, right? So it uses a print server to manage how many documents that you print, right? And then they bill you based on that. They charge you based on that. So now at home, can you set up a print server on your laptop or your Windows? Yeah, sure, you can. It's just a role, you can initiate it. What you can do is you can stop people from printing through it, right? So if I create a print server and I connect my printer to it, I would load the driver, all the drivers for the printers that I need. And so when someone sends a print, it has to go through my system before it gets to the printer. So if I want to cancel a print, I can just click on it and cancel, right? Right now, you don't have print server at home, maybe not, right? But in a business environment, you can do that. And then web server, like I mentioned before, it gives you the web content, what you see as a page on your screen. Okay. The domain name is the DNS. Okay. So the web server is the HTML document that you load, right? The landing page. When you click a tab, it loads whatever. How am I on time? Okay. Then you got, I know fax might not be too modern, right? But fax, in California, there's certain contracts that need wet signature. Meaning what? That you have to physically sign with a pen. You cannot fully sign that document. For example, in real estate, when you close on a house, you have to sign it, right? So there's certain contractual law in certain states that requires signature, and that means that when I signed it, I gotta send it to, I don't know, the company that loaned me the money to buy the house, the lender. So, fact, if you ever go to a dealership, right, and if you're trying to finance a car, right, it's gonna use the old school carbon printer, the roll, right, and then they make you sign for the finance. And then once you do that, they submit the digital fax form to, whoever lends you the money to buy your car. Right? If you buy your car in cash, right, you just sign off your title and that's it. But if you finance, so in California, they still require that. So you do see companies creating fax servers still, right? Fax is really old school. When I was applying for jobs, your age, right, I used to fax my resume all the time. But fax server is used now for contractual purposes. So you see this with like larger retailer company that deals with contractual. Sometimes medical industry they use fax server, for cases and things like that. But we mostly deal with file server and other form of server. So these are just the roles that you can initiate or configure for your system to provide specific service. And then your application server. So application server works like this. You have a system that manages all the application you want to use in your company to the browser. Let's say that I don't want you to use Edge or Bing, right? I want you to use Chrome only, okay? Because, maybe security reasons or my web program only works with that particular browser. Or I want to be able to use application server to manage Microsoft Office productivity software like Word, Excel, PowerPoint, etc. Okay. So we can control how the user uses the application through the application server. So for example, students get access to Microsoft Office productivity software, but not other people in facility, for example, the people who maintain the building, they might not need it, right? So we can control who has access to what through the application server, okay? And that might seem kind of weird, but you see there's like division and departments and individuals and manufacturing company, right? In the manufacturing floor, even the engineers, they have different access level compared to, other areas of engineering. So you got mechanical engineer that they have access to like certain type of software like SolidWorks compared to, other companies. So you do see some of the resources being used that way. And then telephone servers, we would use this to manage. It's important for call center, when you call and you complain about, what's on your bill, right? It gets routed to India, that reaches a call center, or like somewhere in the world. So what happens is those servers, it knows now you got the AI that prompts you, right? Speak to it what you need, and then it determines based on what you tell it on the prompt, and it's gonna route maybe for customer service, maybe for tech support, to reset my password, etc. So the telephone server is just a way for us to route, you know. Now, if you go to elementary school, you know how that they used to call you on the announcement, like, so and so, go to the principal office, right? I used to manage those telephone system. A lot of schools have phased it out. But it uses the old school switch phone system. Right, and then they could only make one announcement at a time, so they would send that announcement, it goes to all the room, right? So basically that gets mapped to all the speaker in the room. Now in the newer system, you do see that you can actually set it up where visually you can announce, you can send the announcement to a specific area, like maybe into a certain building, right? At the school versus all the location. So you see telephone server doing that way. And then I know some of you are highly interested in security, and it talks about proxy server. So proxy can be used in a lot of ways. It can be used to handle tasks to filter internet. I know public school, many of my students, they ended up in IT or security or K-12 public school networks, right? And so you can set up proxy to be able to control how your traffic flows. Like it can act as a traffic police. You know how when they have construction and they tell you can only turn right, right? Someone is standing there and says turn right only, you can't go straight, right? So you can direct the traffic a certain way using proxy. You can also filter traffic using proxy. So if I want to block website, I can also use proxy. You can use proxy to maximize and diversify your network traffic. So for example, I might have a ton of traffic at 9 a.m. when my company starts, right? Everybody's on the network, right? Some uses applications, some are doing other things, some uses internet, etc. So what I can do is I can set up a bunch of different proxy and divert traffic for specific use and use the main bandwidth for priority applications and resources like customer transaction, database updates, because that's money maker, right? So if you're looking at the hospital, the priority areas would be like diagnosis, treatment, doctor systems, nurses, and ER systems, and so on. So we want to use the bandwidth for that versus, other clerical stuff like billing and things to divert traffic to these other areas, right? It's not much less of a priority, but that priority is not immediate where you have ER, PET scan, MRI stuff that needs to have throughput immediately. Okay, so you understand that? Any questions? So proxy can be used in many ways, but you can handle tasks. Okay, so let's talk about hosts. You can have laptop, tablet, server, point of sale system. So POS stands for point of sale systems, like when you put your credit card in. Sales terminal can also be a host if you go to a grocery store. I was at a grocery store the other day, and I was waiting in line, and the system stopped holding. I service a lot of grocery stores when I was a field technician. And I wanted to scream out like reboot, right? But I just did, and I stayed in line, and I was patient, and I was thinking, if they reboot, it will solve all the problems. And then she was on the phone, she talked to her manager, and he was on the phone, and then sure enough, there's support. So, this system, and it's Linux embedded system, and then everything goes, right? So sometimes it just needs refresh like that. Okay. Any question? Okay. Sorry. I don't know why I highlighted that. Don't disregard that. So let me move. Sometimes I put notes in there. Oh, I think I put down that, your host now is also, they're all on TCP/IP, right? It stands for Transmission Control Protocol and Internet Protocol. So the IP part is purely for addressing. Think of like your house addresses in the city. Transmission Control Protocol, that's how it gets routed. Okay, and we'll touch on that. All right. So on 7, I want you to look up some of these devices for the business, and you don't have to be, your answer will be different than the other. So let's try it together. So first, we're gonna look up a router, not a wireless router. So go to Google, and then we can look up router. Right? It's gonna try to give you like wireless router like this, but wireless routers like this is only gonna be for very small business or home use. You can use your wireless router like this, right? But you can say Cisco router. So I want you to see the range of router, $127,000, right? So there's a saying in security that we always buy a box and configure that box, and that's how we improve security. And networking is like that too, right? Your box can be very expensive or very cheap. So in this case, it has firewall functionality and all of these other security components. As you can see, security appliances are very, very expensive. IT security sales is a big industry too, a big area. And then you also have something that's like $10,000, right? Something that's in the 7,000, something that's, so this is an old one. Catalyst's been around for a long time. So I know we have some Catalyst in here. So you also want to look at, so when you shop for routers, you have to think about like, what are you using it for? It's like buying a car, right? I want a sport car if I want to take it really fast, right? I want a truck if I want to carry a lot of large things, right? So when you have routers, you have to think about, what kind of services am I going to use? So it's important to think about like the protocols and the services, okay? And then you can also add in like small business to narrow down your search, okay? And so you can find something of choice. So as you notice, the routers don't have a lot of ports connected. It's only going to have like maybe a few in and out. That's it. It's like the freeway. You can enter and exit. There's no turning right or left or U-turn, right? I know it's actually going to turn about with the highway. But so it's basically routing things in and out of the network so you can see. So you can pick any of the ones that you find that will be relevant. So make sure it's a router. Now, I want you to understand the difference between a managed switch and an unmanaged switch. Okay? An unmanaged switch, you cannot configure. You just plug things in and it's switched. So the job of the switch is to get your data from this system to the system down there or the system up here, right? So what it does is it's looking at the address of the system and it's the actual MAC address. So there's two addresses. Your physical address, which is a MAC address, you have the physical address, and then an IP address is a network address. IP is used for routing. Okay. MAC address is used for switching. So a managed switch, you can configure, right? So for example, I use switch A for this segment, switch B for this segment. They connect together and they would send all the data to the router to go out, right? And then receive the data from the router from the internet or the wide area network. So you can find and some of these are used, so that's why you see. So you can get a 24 port. So each computer that's connected with an Ethernet cable needs a port, a door, okay? So if I have 24 computers, I use 24 port switch. If I have 48 computers, I use a 48 port switch. So in this room, you have 50 computers, they are going to likely use 2 switches. Okay. Now, we'll talk about switch security later. So you're going to see some vary, right? So you notice the switch would have more port connection, more connector points compared to the router. The router only routes in and out. So you only have like either the fiber or some kind of medium connection, the coaxial for the old school one, and so on. Now this one, why is it so expensive? Well, depending on the feature that you have on it, sometimes that could be to the brand, right? So you notice that there's different brands, right? Not just Cisco. There's TP-Link, there's FS, there are other brands outside of Cisco. And then an unmanaged switch is just a dummy switch. It doesn't, you can't configure it, you just plug it in and it's ready to go. Question? You can. So it's out of the box. I just plug the cable in and I'm able to communicate this system to this system, but I cannot configure. So the managed switch, I can configure a virtual local area network with it, so that way I can isolate these roles from the rest of the room. I can configure like DHCP with it, DNS with it. There's other features that you can make a switch into almost like a server, kind of like your wireless router at home. Whereas an unmanaged switch, you just plug things in and it still gets you from one system to another, but you can't control much of it, right? The way that you control is unplug it. So if you're being attacked, unplug the system, that's it. Okay. But you can't like go in and reconfigure it. Okay, so we already know what an access point looked like, right? And then a server. So access point AP tends to be for. So different now. Some at home you have a router that also is an access point. When you come around school, you're gonna have RCCD access point, but the router is the main router of the district. Okay, it is not a wireless router. Okay, at home you have a multiple role in one. So not all access point are routers. Okay, so they might have access point mounting everywhere at the campuses or at the university or in the city to be able to give you wireless access. But all of those communicated back to the controller, which sends it to the router. So your traffic gets access point is like the wireless part of the switch. It brings everything back to the router and the router sends that in and out. And then your server. I just disposed one of the, I will open a new server to show you later. So let's say if we're looking at like rack-based server from HP, and you can get Dell. There are other brands. So it will be something like this, right? You see how the picture looks? And you can find Dell. So you are gonna have multiple Ethernet connection there, right? Because the server provides services to many systems. So on your PC, you only have like maybe one Ethernet for your adapter. So you're gonna have all these advertisements. You're gonna have a lot of the connection, so that way it can provide service. Now, if you rent a server for your cloud from your cloud service provider, it will be like this on their rack somewhere else, right? So if I get Amazon, it will be at the Amazon data warehouse. I just remotely log into it and configure it. So what's in the server? Processing power, RAM, and storage. That's what you need the most. So the more powerful the server, the better the processor. Also your adapter. So I'm able to team knit it. So combine all of this into a team and be able to control and manage it that way. You see how the connection here. So this is a ProLiant. I think we have some HP in the back for that I had bought. But what you see is, you see that inside here, it will look something like this, right? So you still have a processor, you have heatsink, you have memory, right? So when you rent a server with AWS, the more you pay, the more hardware you get. And so it depends on how fast or slow you want for your server. And the free stuff is really slow that we use the free AWS. Right, so it tells you here, you're like, why am I paying so much for 32 gig of RAM? 32 gig of RAM in the server environment is, it's pretty pricey still. And you can up it, but it'll tell you the CPU. So usually it's like Xeon, and you're like, oh, why is it slower than my regular PC? So if you want to upgrade on the server, so their board is a little bit different, right, than your regular. So this is an 8-core dual, so that's going to be equal to 16 core, and it's only at 1.8 with the clock. So that's like half of, these system clocks at what, 4, right, for the processor. So you see that you're going to pay more in price for the little hardware that you get with the processor, because it's just manufactured and sold that way. Question? Okay, so check out some server, and you can just put some URL there for me. So the type of network devices that are used for wide area network, first you need the highway, right? The router. But you're like, well, what's a gateway? So gateway tends to be router. 99% of the time you're gonna hear gateway, it's opposed to the router. It's like a way that you can go into another city, right? But back in the day, and some company might still use this, they use a server as a gateway. Okay? So we can control who comes in and who comes out through the gate. Remember that, right? So a gateway is a way that you can bring things into your network and let things leave your network. But it tends to be the same as your router. And then you would have a managed switch. So we'll talk about the layers later. A managed switch allows you to configure, right, who's communicating with which system. So a layer 4 switch, you can use this with VLAN and voice over IP, whereas a layer 3 is equivalent to a router. So layer 3 is for routing. Layer 4, you would be able to have additional services and resources here. And they are different in price compared to a layer 2 switch. So earlier I talked about managed switch. Some switches, that's all it's doing is to be able to control which system receives and sends inside your LAN. Okay. Now, why a layer 3 and a layer 4 for beyond your network? Because it needs to route. Like your phone call. So if I'm at my desk in my office, right, and I dial an extension at Norfolk, it's able to route from MBCE to Norfolk, right? It's entering a different network, and you need the switch to do that. We'll come back to this. Yeah.
Layer 2.
Layer 2 switch you can only use inside. Like if I wanted to use it to connect all the computers in this room, right, with the next room. Yeah. So layer 2 switch is only for switching, and it creates a table when you send information back and forth. And that switch table is important in security because, you do ARP poisoning and things like that, right? We'll touch on that a little bit later. I try to tie into like the applications and knowledge that you need from network to security, so you see them important. Yeah, so layer 2 is only within your local area network. Anytime that you leave your network, you need to have layer 3 or higher. Okay. All right. A peer-to-peer network, we can think about, like, you guys ever go to those lane cafes? Right now they use like a wireless network. But back in the day, people used to get together and connect system to system, like my laptop to another PC and play game that way. Right? I know some people still do that, right? Like little game group. So internet cafe, sometimes you would see a peer-to-peer, or like I said, if you're able to airdrop, it's a peer-to-peer, right? You guys use airdrop. I don't use Apple system. I have really is an Apple person. I'm an Android person. So you would airdrop a picture to your friend's phone. That's a peer-to-peer environment, right? So you often see this for individual home use. Now, I'm sorry. Question? Yeah, it's equivalent in role. But if you configure the hotspot and manage the system through the hotspot, it no longer becomes a space. Usually it's, it's parallel in role, like your iPhone with another iPhone, iPad with an iPhone, right? Yes. Good question. Okay, so let's talk about logical, and I know I should be moving faster because this assignment is long. Physical and logical topologies. We are going to do topologies today as part of the lab, so I will start it with you, and you might have to finish the second exercise at home so I can show you. So the physical topology is a physical arrangement. Okay. So on Friday, when I walked this room, they're like, oh, we're going to have more desks and computers in this room to all your students fit, right? And we had drawn out the design previously in another way, but because the way that they drop the cable in the network coming from the wall, we cannot rearrange it otherwise. So we're tied to the physical layout, the physical design of the room and the network connection with it, right? Now, if I want to put the desk in the middle and rearrange maybe like hexagon, they're gonna have to drill, right? Either dropping from the ceiling or the floor to be able to connect all the systems together. So sometimes you're obligated to the physical layout, the physical arrangement of your network connections. Most all networks, right, run things through elevator shaft and coming through the fault ceiling. So when you look up, this is a fault ceiling, right? You don't see wires hanging around because if there's a ceiling and there's a fault ceiling and the cables come through that way. Sometimes they have a fault floor, right? In data center, they would have a raised floor. So there's the physical floor, cement, and they would have a raised floor and all the cables running through that way, right? So you don't tip over the cable, you don't see the cable and it comes into the wall. So that really gives you the requirement on how you would arrange your desks and your systems that are connected with the cable in the network. The logical topologies really shows like how the data go from one system to the next, right? Sometimes you're gonna see the topology is drawn exactly the same. But a lot of the time, the logical topology, the layout of the data flow from the system is more of like a higher level summary, kind of like an outline to your paper, right? So it's really telling you, oh, okay, there's this rack. So the server is gonna handle, and then that's gonna get sent out to the uplink switch, and it's gonna get out to the router, and that's gonna come out to the WAN, right? Which is the cloud that we represent, and then all the switches within. So you're gonna get topology layout drawn, right? Really shows how the data is coming across the network or in and out of the network. Sometimes it's the same, the majority of the time you might see it's different. Okay, so a bus topology is just like, let's say I want to connect system 1 to system 2, right? I just connect and it's just a straight line. Now, back in the day, that was the only way that we connect, right? One system to the next, and we might have to have multiple adapter to connect the cable. So it's easy to install back in the day and it's low cost. Nobody really uses a bus anymore because this layout in a security perspective, if I kill your source, you're done, right? So let's say that if the data flows from this system to the end, like look at your role, right? from where you're sitting to the other system, if this system is sending data, I'm gonna target this system and kill your data here. Right? If I want to get your data, I just go down to the end, the destination system, and I target that. Right? So a bus is not a good way anymore outside of just, the lack of administration and also the lack of security, single point failure. So if somewhere in the middle, the second system, if it's down, there's no receipt, right? If I'm sending from here to the end, think about like there's one street that you go on, and if that street is shut down, you can't go anywhere, just stop, right? So that's one path, and you kill that path, that's it, right? So that's a huge security flaw. When I look at security, the first thing I look at, how is their network, right? And sometimes when we assess, like when I assess, they don't give me a lot of information because they're like, oh, here's the network. Right, and then I will find out, oh, there's this, and there's that, and this is a problem. And they're like, oh yeah, we forgot to tell you about that, right? So you want to make sure that you don't have a single point failure. I don't want to kill a system and no information is passed. You want to have fault tolerance. You guys know what that means? I know security students know what that means. An alternate way to do something. To send data, to receive, right? To communicate. It's kind of like a backup plan at home in case of emergency, right? So it is an alternate way to route an alternate secondary system. So you need to have fault tolerance. Okay, a star topology. You have a central point with all the things connected to it, your whole network. What's your central point? The wireless router, right? If I tell you a wireless router, what happens? It's done. No internet. And if there's no internet for a few minutes, everybody comes on. Oh, I can't game. I cannot watch YouTube, right? I'm not streaming. So the good thing is you can manage it very well. I just need to go to that central hub and configure it, right? Easy. So your administration, you can add more systems to it, right? If you want to add more cable, it's easy to troubleshoot. Because if someone tells me I have no internet, the first thing I'm going to say is reboot your computer, maybe get a new IP address. Second, all right, simple. Is it going to be yellow, right? Or is it green? Right, so LED lights. So we can troubleshoot. The disadvantage of star topology is that, and I'm entering, so let me move 11 down. We're okay, right? The disadvantage is that sometimes costs can be a lot, especially if you have more system and more cables. But you have a single point failure. Like I said, right? If I want to kill your internet, I target your access, your wireless router. It's really easy to also plug, right? So we have to think about this when we design a network or modify a network, right? How our layout would be. So, sorry, did I cut off someone? 13. What's the type of network topology that's rare in today? Kind of mixed. So a ring. So a ring is just a circular bus. So if I send from system 1, right, I would reconnect the ending system back to the system 1. So I think the cost on the ring is more. And then a mesh. So a mesh would be interconnected, right? So I would be connecting from this system to the middle system, and that middle system is connecting, back to this system. So you're gonna have like a star within a ring. So that's a mesh. So that means that there's more cable, there's more adapter, etc. Question? This is one way for me to give you the terminology without making you read on your own, so that way, hopefully my example sticks with you, right? You take the example, like, oh, she said, it's such a three-way. Okay. So we can have a point-to-point topology in the network. You can have a router to a router, a switch to a switch. That's very common in a network. Right? We talked about here, here, here. That's a point-to-point. But a point-to-point. So when do I see this? Okay. So that means that I can, so let's say that you have multiple campuses, like the way that you have three colleges, right? In order, we might have like MVC networks connecting to a Norco network, or you might have branches like a bank, right? You're gonna have a router to a router. Okay. And then within the network, you would have a switch. This room, this computer room, connecting to the next part of the network, which is the next computer room with the switch. So that will be an example from point to point. And if you missed something, you can go back and watch the video. I know that the old video probably has something on there. You can have computer to computer. You can have a switch to a router, which is very common in a network as well. A computer to a switch. Many different examples. So that's basically a point is a system connecting to another point, which is another system. And all of this information, again, you can also go back and read your notes, right? I put together the notes. It's not just from one textbook, right? I supplemented some of the resources to make sure that you have all the things that you need for class. Any question? Just have about 8 more to go. We're good. Snacks up front in case you need something to pick up. And then if you need restroom or water, you're welcome to do that. Okay, can I move 13 down to the next page? I think we're good with 12, right? And again, you don't have to put verbatim. You can also summarize answers. I just want to get the cutoff here. Okay. So if we want to connect one point to multiple points in a network, at home, you already have that, right? You already have your wireless router, and you might be connecting your game computer, your printer, maybe other systems to it. So, but in a regular network, you might have one router connected to multiple routers, one router connected to multiple switches. Okay. A switch connecting to many computers. Like we talked about the 28 ports and the 24 ports and the 48 ports. You might have one switch that connecting to 48 computers. So that's another example. So when you put together the layout or the topology of the network, financial part consideration is always going to be the first area. How much cable do you need, right? Because cable can be far, cable can be short, what kind of cable. And again, you looked at the appliances, right? They can be $10,000 or they can be $125,000, right? So the cost. What's the insulation like? Okay, so rule practice, important. Label your cable. Color code is crucial because nobody wants to troubleshoot a messy network. Okay? You ever look at people the way they connect electrical stuff and it's like crossing and twisting, and then when you unwind it, it takes you an hour to unwrap the electrical cable, right? So it's always good to, when you install a segment of the network or fix the problem, right? You need to make sure if they're using blue cable, use blue cable. I know it's colorful to add other color, but it's because that color is pertaining to a segment. So whenever that you troubleshoot, you can quickly see which segment. Always really good. Excellent. You can use like, they use sticker or those wraps to be able to label, and some cable you can actually write on it. So it's that's just a rule of practice. Easy of installation, easy of maintenance. Okay, think about that. Not always easy to maintenance. So I had a former student. He was hired for the job and they pay him really well. His first task was to re-cable and redo all their closet. Whoever that did that, and he took a picture and he sent it to me, and I was like, good luck to you. Let's spend 2 months with it. Right? So I told him, I was like, start to narrow down one piece at a time, right? And then color code and label. And then that way, and then you document as you go, so that way you can easily fix the problem. And then whoever that's maintaining that next, that it's so helpful, right? And everybody wants a cleaner network connection, so. And then fault tolerance requirement, making sure that we think about if we have an alternate way to communicate and have secondary system, and then security requirement. This should make the list a little higher, right? In my opinion, but usually in most companies it's last. So unfortunately, the security requirement. Okay, so we talked about LAN, we talked about WAN, we talked about MAN, so metropolitan area network. The best way to describe this is if you ever go to like downtown Riverside or the port area or a university, right? You see metropolitan area network. It is not as big as LAN, right? Sometimes it's not span as LAN. But it is a way that you can connect like a court building in the civic center, right? To maybe, I don't know, in city of Rio Valley, they have like, area for the city hall, a convention center for the actual city, etc. So those physical buildings have interconnections, right? And sometimes wireless connection as well, and that's a MAN. MAN. For the campus area network, this is more common with university and colleges, right? Hence the name. You do have a lot of buildings, right? Like I was visiting Berkeley over the summer, just to go from like the downtown part of Berkeley to come up their new hall. It's like a 20-minute walk up the hill. And you would see they have a lot like engineering buildings, actually engineering department, they have multiple buildings. So what you have is you have several buildings that are connected. Nowadays we use fiber optic to connect one building to the next, right? Because we have the capability to do that. Back in the day, they used coaxial, your cable, cable, make those, right? Or even slower phone connection, which is the dial-up era, right? So you often see like a campus environment. If you ever visit Cisco in San Jose, right? If you say they call it a campus, because that whole entire multiple blocks is owned by Cisco building, right? Each building they do different things. Same thing with a lot of the memory companies or something. So can't. So what is the purpose of your storage area networks? And some of you have heard this before in A+ class. So basically, SAN, S-A-N, or storage area network, it is a way that we can manage our data and files, right? You can use SAN for your file server. You can also use network attached storage, NAS, which is a different thing, for your file server, right? but it is a way that we can organize the hierarchy, right, of our data and manage it. Okay, and how we use it. So we can create containers and subcontainers. And like, for example, I might run like a media streaming company. I might have different categories of video or, the type of, for example, like anime compared to action, compared to etc. And I want to be able to tie this back into the database table. So the database, all that is just gonna link back to the actual file server. Because we don't store the file into the database, that will be too large of the storage. So you would use something like that, right? So this is a way that we can manage like container the collection of your data. Can you buy this for home use? Yeah, if you have the money, you can do this, and you can I have some friends that like they love crazy storage, so they would have their own streaming server at home. And all the DVDs and stuff that they Blu-ray, they uploaded it to their own, they have like a collection of, movies, so that way they don't have to pay for streaming service. So that's like it's been going on for a while for a lot of people. So sometimes that they would pay for something like that. And you can look up the price on how much. And it really also like the hardware that comes with it too. Okay, so now let's talk about your coaxial. So when you come back from the holidays, remember next Monday, no class, right? You can show up or what you do. The parking lot will be empty. But the following Monday we will be here, right? So we're gonna make your coaxial. One, you're gonna see that back in the day they used the net. Okay. It is a form of coaxial. So when I say coaxial, what does it look like? I put it in the other room. I should pull it out. But we'll do that when you come back. It's your round copper cable. It's like the size of your finger, and it has a needle in the middle, right? You use it for cable TV. Right? If you have a cable box, you have a coaxial. Right? I know sometimes they would use it integrated for DSL and other type of satellite service. Okay, so the old coaxial is called thin net. When you're looking at the number like this, the 10 here represents the speed. Okay, you're gonna see later on that we're gonna have a different base where it's like 1,000 base, right? When you're looking at a newer cable type, you're gonna see that there's like 100 base or 1,000 base. So that represents the rate that's sending the data. The base 2 is the standard for it. So the thin coaxial cable, it uses the RG58 connector. So you know where that needle goes and that twist and you plug it in? It's slightly different than the newer cable, which is the thick net, which uses RG60, right? So if you look at the older houses, if they have a coaxial drop, right, likely that is a thin net, right? The RG58. And then when they stop having the device to adapt to it, they have to come back and install the cable. Okay, so that's a coaxial. And inside it, you would see that it's copper. Why is it copper? Because copper is cheap to make, right? And still the majority of our media is still copper. Okay, now you have a thick net, right? Which is a different base. It's still 10. So coaxial is really standardized for a certain speed, right? I remember people would get cable packages before fiber optic, and the maximum you're gonna get is what? 10, 20 megabit per second, right? It's a huge upgrade from DSL, which was really slow. But it's really pertained to the throughput that you have on your cable, right? Your cable, that path, it's kind of like that road, right? It's really narrow and you can only drive a certain speed. So your media is that way. It's limited to that path to how much data you can send. Now, if you want a bigger, better path, you better change the media, go fiber, which is light based or laser based, right? Okay, so. Now, on the thick net, you see that huge upgrade, it's able to accommodate more systems, right? And it's able to share higher bandwidth. So you are able to have better throughput or performance in your network. So whenever that you see Ethernet, it is classified with IEEE as 802.3. This is on and on a lot of the certifications, especially Network Plus. So whenever you hear Ethernet cable connection, right, it is 802.3, right? And you know that wireless is 802.11, right? So we need to start remembering these numbers because it's for the standard from IEEE. And ThickNet allows you to go up to 500 meters. This is why they're using it for cable TV, right? Because if you ever watch the installer, some of my farmers say they also need an installer. I mean, it is a big job to start if you want this a big job, right? So you install it. Where does it go to? There's a cable box in your living room, in your room, etc. Right? They run it down to possibly your garage because it needs to go to the demarc of your house, right? Which is a way to go out to your street. Every street tends to have some form of box on location where all the cables of all the houses go, right? So technically, and they can adjust how much can be distributed for that street, you know? In my neighborhood, it's not an up and up neighborhood. So I always see that box open. People be tampering with that stuff and sometimes, but you know, so when I started learning this stuff, I'm curious, so I always try to follow the cable. So it goes usually to your garage, your demarc boxes tend to be in the garage or behind your house somewhere in your apartment. And then it's gonna go out to the street. So technically, your bandwidth is ultimately what? Shared with your neighborhood, isn't that true? Right? Even though you pay for it, right? So I pay for a fiber package, but my fiber is to the main street. It's then come back to my house as a coaxial. It's kind of like paying for a sport car, but you can only drive at 60 miles per hour instead of $50. I don't know why. I mean, we still get the speeds that we need for whatever we need, but still, right? So, now that you see that perspective, you have to think about that when you're buying an internet package. Okay. So now let's talk about fiber. Okay. So when we make the Ethernet cable, right, you're gonna see UTP, which is unshielded twisted pair. All the Ethernet cable, they're all twisted inside when you open the UTP. And you have to untwist it to arrange it so that we can put it into the connector. Okay. And then you have STP, which is shielded twisted pair. So what's the difference? If you ever cut open an Ethernet cable, a shielded twisted pair does what? It has a foil wrap before the plastic coating. Okay. The majority of the store, if you go and buy an Ethernet cable, they don't sell shielded twisted pair. When do we use shielded twisted pair, your STP? Is when you have a lot of cables connected together, like in your closet in your server room. Okay. Why is that? Because there's leak. Okay. Signal leaks when you have a lot of cables together. They're signal leaking across, and sometimes you lose data that way. Okay. Most network they might not use STP because it costs more. Okay. Most of the administrators run UTP. But you have to think about like the critical of your data and how much signals you can deal with. Okay. Because all cables except for fiber, right, have leaks, okay? So when you do that, all the cables together, it's very noisy. And then you're gonna have like, intersection between. And that's the same thing with what you see with wireless and other things. So if you're using a twisted pair cable, you can use it with a 10 base T, right? A 10 base T is 10 base T is for, 10 base, what you see is with the copper coaxial. 100 base TX, right? Or 1,000 base TX. So when you see the TX, that start to be for fiber optic right here. Okay, so 10,000 megabit per second, this is what you see with the gigs, right? Okay, so the higher the number, the higher the speed. And in modern technology now, we have the higher rates. Okay, so you should use, and those tend to be, if you have a lot of cables together, you should use STP, standing for shielded twisted pair. Okay, that means it has a full wrap inside the coat. All right. So now when you go and you say, oh, Dr. Wing said that I can practice making cable, right? We will supply all the stuff for you here, but you can buy your own cable kit if you want. Some students, they love it so much in the last year, they have their own cable kit. You can't, you can find. You can also go to Home Depot and they sell it. It might not be as cheap as Amazon or other places online, right? The most of the network that you see, they still using Cat5e. This is basically a type of cable, a type of Ethernet cable that is used to connect the system, like your computer, to a switch. Okay, and Cat5e uses Cat5e connector. Okay, now some people would use Cat6. Does it make a huge difference? The cable is tested and classified as Cat5e or Cat6. There's different. It's kind of like you're gonna have two model of car. One is newer and one is older, right? The newer might have more feature, hence Cat6 have higher speed, which is your frequency. Okay. So am I gonna rip out everything in my network and replace it with Cat6? Not necessarily. That might not be ideal as cost, right? Some administrators may be enough to do that. But it's gonna work until it can't, and then they're gonna rip it up and then install these, right? So if you look now, there might be Cat7 and other things, but if you enter a lot of the network, you're gonna see Cat5e the majority of the time, right? And it's cheaper, so they're gonna install that. Okay, so we are gonna make these cable, right, along with the coaxial. I know this is long. I'm sorry. Because I'm trying, this chapter has everything, and then we're going to come back to some of the subparts. But you can find this in the notes. So let's talk about fiber optics so you know. Everybody said, oh, let's get fiber, right? You go to the store, you want a fiber cable. I have fiber cable for my audio. Like if you have surround sound system in your home, likely obviously like your sub and your speakers, right? If you buy my home theater system, kind of that comes with a fiber cable. Is that better than HDMI? Well, if you have to look at like the quality and what you want out of it, okay. But however, in data communication, we're going to look at these two categories: your single mode fiber optic and your multi-mode. Okay. So ultimately, how it sends your data is different. Okay. So if you want long distance, right, using one single strand or sometimes two strand, and if it's glass based, the structure is different. You're going to use single mode. So this one uses LEDs or laser. But old school, they uses laser. I think some still do, and then or you can find some that has LED. Okay, so what it does is it's going to pulse the light, right? And that's how it sends the data. So that means that it's going to be 50 times further than your multi-mode. So if you're looking at Google, you know how they avoid paying tax to San Francisco because San Francisco gives them a tax break when they first Google store start up and say if you build a startup here, we're gonna not charge you tax for 10 years, right? So the 10 years is up and Google's like, oh my God, we're making this good money. So now we're gonna have to pay this to the state, right? And so what they did was they said, instead of having a physical location, which we do, it's not, we're gonna put it on a ship in open water, it's not, right, in the lake. But we need data. So how the heck are we gonna be able to get data to our ship? Guess what? They just run a tunnel with fiber, do it, and Google does have a fiber service, right? So keep in mind that single mode, even though it's using 1 or 2 strands, it's really made for long distance further, right? So if you own an island one day that you won the lottery and you want high-speed internet, you're gonna run fiber to your island, right? And you're going to build a tunnel, run the fiber modes into it, right? So this is what you see. Now the multi-mode, okay, it also uses light. And light, you don't have deterioration in signal. This is gonna go further, it's more reliable, hence it's fast, right? Definitely fiber is here and it's here to stay, right? So what you see is the multi-mode, the difference is that it does have a reflection, right, structure where it's gonna disperse the light from its source, okay? And it's gonna do a bounce back. So it's gonna give you higher the speed, but in the shorter distance. And that's standard in all communication type of technology. If you want to go further, you're gonna get slower speed, right? If you want to be shorter, you're gonna get higher rate, but in shorter distance. So think about that. 5G versus 2.4. I know you guys know this. You're on a 5G network, you can't go far, right? You can connect at high rate on 5G, but how they provide 5G for mobile devices is that they have one big tower, right? More cell tower to relay the signal so that way you can have 5G. But if you're using 5G in your environment network at home, right? 5G is for high throughput, but you can't go far distance. If you want far distance, like most access points you see in LAN or in CAN network, it uses 2.4. Okay, so you can go standard longer distance, and that's the same. Okay, so remember, multi-mode, higher speed, right? But you need to use it for shorter distance than the single mode. And it is inconsistent compared to the other. It is also glass core. So back in the day, I had gotten rid of some of these things, but you have to splice fiber, but now they have the way that you can actually splice very easily. Okay. And then, so that way you can have, it's easier for install. So that's basically the summary of that. You can find this in the note if you want. So it can go up to 3,000 feet. So this is why when you go from one building to the next, you should use fiber. Some old school places, they say use coaxial, but ideally you should use fiber. So if I go from one floor to the next floor, what kind of cable should I use? Ethernet? What Ethernet? Like at home, if you have a 2-story house, you can, right? Yeah. But what happens when you go further? Deterioration in signal, right? You're gonna have some latency, delay or losses. So your performance is lost in that. But in a business environment, like a school like this, or when you have multiple buildings in the tall-rise building, should I use coaxial, Ethernet, or fiber? Fiber. Yeah. Back in the day, we only used fiber core, like to the WAN, but now we use fiber in between, right? That's best. Any question? So now you kind of understand a little bit different. Not all fiber optic are made equal, right? When you go to the store, and I put the pictures in your notes so you can see that the connectors, right, the type of connectors, the type of fiber that you're buying, right? Not all fiber cables are the same. I do have some equipment I can show you, next time when we come back for fiber optic. So long. Sorry, I have to move forward. Is that okay? All right. So, fiber needs panels, right? Back in PSC16, we actually have a huge fiber box that we contracted and had somebody install, but it would be referred to as FDP. If you're interested in becoming a fiber technician, I can give you some resources for maybe studying for ETA, and then you can, go that route. You want to install fiber. So the panels ultimately is a way that we can terminate or distribute fiber cable. You do see this in, we call it the closet, where all your system is connected, all your racks. So it would have like a tray to manage all your cable, and it would go to the switches or the router, the router, and then the switches to your other locations. So often if you work for a corporate office or a location where it managed the entire network, you often would see fiber distribution panel. Okay. And now you can also be the one that installed this. The engineer that we hired just to put in the box for NBC when we were at the portable, they charged us $8,000 after assessment. It was like maybe a few days job. And then, they just connect that box to the rest of the network, but the district offices actually configure that. So sometimes that can be, quite a good amount of money if you do that as a business. Are we okay with this? So broadband and over power lines your BPL technology. So this is for digital communication using electrical power. You tend to see this in rural area and also different parts of the world where they're still relying on, like phone technology for dial-up or even DSL. So this is a way that we can utilize frequency, which is ultimately all electrical systems have electrical signal, which is, giving us frequency. And it allows us to be able to use the power line as a communication line. Instead of using the actual medium like a cable that sends data. So sometimes that you would see BPL, right? And so in the frequency for the radio spectrum, it's slightly different. It's similar to kind of wireless where it sends it over the air. However, right, it's using a different range of frequency and making sure, there's always a risk in using this, not just health risk, but risk in like data loss. We always look at that, right? So when you use a certain technology, you always have to look at that from that lens. What are you using it for, and how long of a distance you need it for, and what kind of communication, the data, the sensitive data or not, and what you want out of it, right? So there are technologies that's available. We just have to pick the right or the appropriate, I shouldn't say the right one, because there's no right solution, appropriate solution for the purpose. I thought that I had. Okay, I'm gonna move 23 down. Is that okay? Yeah, I try to wrap it up for you guys because I know some of you are getting tired of lecture. Okay, so we're gonna come back to this particular topic on number 25 when we talk about switches and routing. But this is I'm definitely gonna guarantee you it's gonna show up on network plastic. Even back in the day when I went through it, this was something that is with us with communication, so. CSMA-CD and CSMA-CA. You have to know the difference between these two. So the CD, that's really for collision detection. In network, there's always collisions, right? And how it sends the data through your cable. Just think about it this way, like there's gonna be accidents on the 91 freeway again, right? No matter what. So in the network, when all the cable is sending data, likely that you're gonna have data kind of bump into each other, totally collide, right? Signal is gonna, get together, and then so what you're gonna see is in Ethernet technology, what they use is they have to be able to implement something that's going to be able to detect that when data is being transmitted. So what they did was they created CSMA-CD to be able to look at the signal, right? And making sure that there's a weight in between so that way there's not a lot of data loss when it collides. Okay. So that means that it has to stop the frame from transmitting weight to be able to get the other data, the send data through before it resends. Now your switch does this. The smart switch is different than the hub in that it would be able to detect who is sending. It's kind of like you're driving on the road and someone is leaving the gas station, right? They have to wait for you to go past before they enter that road, right? That lane, right? Because if you don't have detection in collision, cars gonna be bumping into each other and you're gonna have a huge traffic holdup, right? So in the network, the same thing. You can set up a way that where it's saying, oh, there's a car on the road, I must wait before I enter that lane. So the same thing, it's gonna pause that frame and it's gonna wait for that signal to go through and then it's gonna resend the frame. So that way the data will get unfolded because if you have a lot of collision, what will happen is it will never get there, right? So before the switch, when they used the hub, everybody was sending. And then nobody is knowing which one is locked. So if you send to me and I don't receive it, oh well, right? Let's try it again. Might get there, it might not get there, right? So when they created the switch with this particular feature, what will happen is, oh, it needs to resend if it doesn't get there, right? It's able to detect. So that's important to think about. And it uses your media access control method, so it checks your MAC address. And then the CD is used to improve performance, so just know that. And it's gonna retry or resend. So if you go to this part of the notes, you will find all of this information. That's where I got it from. So you can summarize it if you want. So in 2011, they had added some repeaters, and then it uses the half duplex, and we'll talk about full duplex and half duplex later on, and to be able to have the collision avoidance. So the difference between the CD and the CA, one, the CD is the detection. Two, CA is the avoidance. It's actually gonna avoid the collision. It's kind of like there's car driving on that road and I'm entering that lane, but I see the car and I swerve, right? So it's able to avoid by sensing that node is sending. Okay. And it puts it again into the idle or the wait mode before it transmitted. So it's similar to the detect, but it's actually, so ultimately these two gives us the opportunity or the system opportunity to make sure there's no collision. One is the detection, second is the avoidance. So they often go together because it works together to be able to make sure that your data gets from source to destination, A to B. Understand? Any questions? Okay, make sure we know this because I'm pretty sure it's gonna come up on your certification And then it talks about the benefits and the disadvantage. Okay, let's see. Just a few more and we're good. Can I go to 26? And I think my video is on the video page, so you can go to that. You can pause if you want, or you can go to the notes. Okay, so let's talk about modulation, right? I know that you're familiar with radio, maybe, right? For AM, FM, and so these are the type of modulations that we see with electrical communications. And then for 27, we talked about this as being the speed. So whenever you see the 1,000, we're already entering the fiber mode, right? So when you're using the cable, if you're using 802.3, and if you see the Z here, likely that you're going to use fiber optic, okay? So the type of cable that you use for LX, this is to give you a way, so you see the X, and if you see the 1,000 base, that means that you're using fiber, and it uses single mode. We talked about single mode difference and multi-mode. So if you're looking at, for this particular classification, classified standard, right, we're using the fiber for that. And then for 28, the type of network information service system of this will be referred to as NIS. So this allows you to have client server directory service protocol, very similar to what you've seen with Active Directory today. When you log on to your email account, you're using a user account, right? Your student email and your password. Basically, it refers to the directory of users on the network to be able to determine who you are and what you're allowed to do. Now, the directory services for the distributed system is similar. It could be automated system like the autonomous router for AT&T. What it does is it has a list, right, of system that has associated services protocol that would be able to manage and how it passes the data. So what you see is your network information service, all that is referring to a list of the system and what it's given as a service for a specific system in that network, right? So it's just another acronym, but understand what this does, right? And it refers to distributed system. So what we mean by distributed system is systems that would be able to send information data to other systems, able to span out and distribute that data to the rest of them. Okay. Questions? So I know it's overwhelming, right? For some of you, this information is very new, right? I sometimes is very technical in my delivery of stuff, but this is something that's looking for many decades now, and it will get better. I promise. If you keep using the terminology and understanding it and rereading it and going through it, it's gonna be easy. Okay? Because I know a lot of students are like, oh my god, the first day of your class in security was like super hard. Right? And we're gonna repeat some of this later, so I promise. All right. Any questions? Okay, so I'm gonna stop and re-record for the second part. I want to give you guys a little bit of a break, maybe bathroom break and snack break. Get up a little bit. Like let's take like 5-7 minutes break, and then we'll do the lab, and then we'll call it a night. Okay, and then I'll take attendance after that. So let me end my Zoom.